Okay, now we'll discuss about crystalitics and unit cell. And in crystalitics or unit cell, the chapter in main important points. The whole chapter we have to discuss related to that crystalitics and unit cell. Earlier we have already discussed about crystalline solid, amorphous solid and different types of crystalline solid. Now we'll discuss about crystalitics. So first we have to know what is lattice. What is lattice? অনেক definition আছে. So one of the best definition is regular arrangement of constituent particles in 3 dimension. In 3 dimension is known as the crystalitics or space lattice. অনেক ভাবে বলা যেতে পারে. What is crystallitic? The regular arrangement of constituent particle of the crystal is known as crystalitics. Alright. তো যদি বলি regular arrangement কি? মনে করো this is one point, this is another, and এই পয়েন্টগুলো অ্যাকচুয়ালি take for example মনে করো এটা একটা atom, this is the nucleus. So এই চ্যাপ্টারে in crystallitics will only say that atoms will be considered as a point. Whole atomটা will not draw it, will only draw the point which will indicate that atom. Regular arrangement. Next. This. Take for example, this is the regular arrangements of the points or the lattice points. Each point in this lattice, each point on this lattice are considered as lattice point. Lattice point. So each point are considered as point lattice. So what is crystallitic? আবার বলছি, the regular arrangement of particles in 3 dimensions. That is the crystallitics or the space lattice. And each point of this lattice are considered as lattice point. Next, holo unit cell. Unit cell. So what is unit cell? The smallest three-dimensional portion which repeat in different direction to produce complete crystal. So what is unit cell? Unit cell is the smallest three-dimensional portion which repeat in different direction to produce the complete lattice. So now we'll know what is the unit cell exactly. Take for example this point, join. Now from there this point is considered. So this is the unit cell, that is the smallest three-dimensional portion is the unit cell. If we will generate this unit cell, taking this point, take this point, take this, once again same unit cell, that is repeated. So repeated, then we will get a complete crystal. Take for example boundary wall বা আমাদের বাড়ির যে কোনো ওয়াল কনসিডার করে, একটি ওয়াল কমপ্লিটলি প্রডিউস হয় কি মানে ব্রিক লাগিয়ে 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 কন্টিনিউয়াসলি যায়, তারপর কমপ্লিট বাউন্ডারি ওয়াল হয়, এন্ড ইচ ব্রিক ইজ কনসিডার্ড অ্যাজ দ্য ইউনিট সেল. সো ইউনিট সেলের ডেফিনেশন হলো, নাও উইল হ্যাভ টু নো এক্স্যাক্টলি in this chapter we will consider the unit cell is the cubic unit cell. Cubic unit cell. Cubic unit cell. What are the different parameters that characterize the unit cell? We'll learn this thing. Suppose this is the unit cell, and in that unit cell each corner of this cubic unit cell is occupied by the atom. So in a cube, take for example this is our cubic unit cell. In this cubic unit cell, how many corners? 1, 2, 3, 4, 5, 6, 7, 8. And each corner of this unit cell is occupied by the atom. Alright. So in total, how many phases it has, that cubic unit cell? 1, 2, 3, 4, 5, 6 phases are there. So what are the different parameters that characterize the unit cell? Considering the axis, let's suppose this is x-axis, y-axis, z-axis. So this is, now suppose this is the edge length A, B, C. So what are the angles between them? Alpha, beta, and this angle will be considered as the gamma. Now we will write these things separately so that we can get a clear idea about the what are the different parameters that characterize the unit cell. Parameters. Parameters of the unit cell. Parameter of the unit cell. First is the edge length. Edge lengths. Edge lengths are considered as A, B, C, and Roman number 2, angles. Angles such as alpha, beta, gamma. These are the two parameters which characterizes the unit cell. And one thing we must remember, this angle is situated, alpha angle is situated always between B and C. Angle B and C. Beta is the angle between A and C, and gamma is the angle between A and B. So unit cell is okay. Now we'll discuss about the types of unit cell. Types of unit cell. So unit cell are generally 4 types. Unit cell are generally 4 types, but in different types of book. অনেক বইয়ে ফার্স্টে প্রথম 2 types বলেছে, তারপর 4 types. So we'll go for this, but in general unit cell has its 4 types. So first one যেটা বলা হয়, that is simple cube. Unit cell simple cube unit cell আর এটারে centered unit cell. This simple cubic unit cell কে আরেকটা নাম বলা হয় primitive unit cell, and this centered unit cell once again classified into three different classes. First one is the BCC, body centered cubic unit cell. আরেকটা হলো FCC, face centered cubic unit cell. আরেকটা end centered unit cell. আরেকবার বলে দিই, first we have discussed today what is crystallitic. Crystallitics is the regular arrangement of the atom in three-dimensional space or portion to produce the complete crystal, and each point on the crystallitics are considered as lattice point. Next one is we have discussed, that is unit cell. What is unit cell? That is smallest three-dimensional portion which is repeated in different direction to produce the complete crystal. The different types of unit cell. So unit cell are, now we have seen that unit cells are four types. That is simple cubic unit cell or primitive unit cell, and according to centered cubic unit cell, body centered, face centered, and end centered cubic unit cell. These are the four different types of unit cell. Just now we have a look how actually that unit cell looks like. First one, we will draw the simple cubic unit cell. This unit cell, simple cubic unit cell. In this unit cell, atoms are situated at 8 corners. Alright, and in body centered, we'll discuss each of these things separately here. Just to have a look how it looks like. In body centered cubic unit cell, it has 8 atoms at 8 corners, along with 1 atom at its center. In face centered unit cell, it will have 8 atoms at its 8 corner, and atoms are situated at each phases 1, 2, 3, 4, 5, 6 phases. Take for example, suppose this is the cube. So 8 atoms are situated at 8 corners, 1, 2, 3, 4, 5, 6, 7, 8, and 1 atom at this phase, 2, 3, 4, 5, 6 phases. And in case of end-centered cubic unit cell, it has 8 atoms at its 8 corners, along with 2 atoms are situated on 2 opposite phases. Here we are considering 1 atom at top and 1 atom at the bottom phases. These are the 4 different types of unit cell. Now we'll discuss each and every unit cell separately. Their number of atom that is contributed by the atom. Numbers of atom contributed per unit cell. Number of atom situated per unit cell. So first one will take simple cube. Simple cube. Let's will draw a simple cube first. Simple cube. Alright. So in that cube, which one will be the simple cube? Simple cube is that unit cell. It has atom at its corner only. 1, 2, 3, 4, 5, 6, 7, 8 atoms are situated at its 8 corner. So which one will be, earlier we have discussed about the cell parameters. So in that cube, A, B, C, these are the edge length. All are equal as it is a cube, and alpha, beta, gamma, each angles are is equal to 90 degree. These points have to be remembered because as we are discussing about the cubic unit cell. Now you have to remember, so here only atoms are at the corner. How many corners are there? 8 corners. So at 8 corners it occupies 8 atoms. Take for example, here is one atom is situated. Alright. So now we have to consider how much part of this atom is contributed to that unit cell. How much part of this? If we draw like this. From this diagram we can consider that only 1/4 part of this sphere. We are not considering because atom is in 3-dimensional. So here only we are looking from this diagram, we can get a 1/4 of this sphere is occupied by this cube. Same way, take for example this is. If a atom is there, then this part, only this portion will occupy 1/4 of this atom, and same way another cube is there, means another unit cell. So this side also, it will also contribute equally. That means each atom at its corner, it will equally share by another 8 atoms. So its contribution will be 1/8. So that will be equal to 1. Write it down. Next one is its coordination number. Its coordination number. So what is the definition of coordination number? Coordination number simply the number of nearest atom which have directly contact to that specific atom. Got it? Once again I am repeating, number of atom touching to a particular atom. Suppose we are considering this atom. So from this diagram it is clear that from this diagram it has directly contact with this, it has directly contact with this, it has directly contact with this in that unit cell. Same way this side also another unit cell there, another atom will be there, this side also another atom, this side also another atom. So that means this specific atom is directly contact with another 6 atoms. So its coordination number will be 6. So in a simple cube, number of atoms contributed for each atom, that means in this simple cube it has as a whole, it looks that 8 atoms are occupying at 8 corner, but as a whole its contribution is only 1 atom is present. Coordination number is 6. Now we'll discuss about the relationship between relationship between is age length, relationship between is age length and radius of the atom. So suppose we are considering these 2 points, because this is a cube, so all sides will be equal. So suppose we are considering its age length is A. Now suppose this point, this point. So these are the 2 atoms. So atoms are actually like this. This are atom in contact with each other. These 2 atoms are in contact with each other. So this is the radius, this is the radius of this atom. So what is the age length total? It will be 2r. Or we can say radius will be equal to A by 2. Clear everybody? Once again I am repeating, for a simple cube, relationship between age length and its radius is A is equal to 2r. That means age length will be equal to 2r, or r is equal to A by 2. Now we will discuss our second unit cell, that is body centered unit cell. It is BCC. So earlier from this diagram we can say which one is the BCC. It has a atom at its each corner and one atom at its body. So if you draw the diagram, it will be like this. Like this. 8 atoms are situated at its 8 corner and one atom will be at the center of the cube. Alright. Now we'll calculate the number of atom per unit cell of BCC. So here corner, total number of corner is 8. Total number of corner is 8. So 8 atom is situated and contribution of each atom will be 1 by 8. So that will be equal to 1. Body centered atom only 1 and contribution is also 1, so that will be equal to 1. So total number of atom contributed per unit cell of BCC will be equal to 2. Once again repeating, total number of corner in body centered unit cell, 8 corners are there. In 8 corner, 8 atom will be occupied. So 8, and contribution of each atom will be 1/8 of its part. So 8 into 1 by 8, that will be equal to 1, and 1 atom will be at its center, and it will be whole atom will be contributed to that unit cell. So 1 into 1, that is also 1. So total numbers of atom will be equal to 2. Oh, earlier I forgot to tell you, this total number of atom contributed per unit cell. This is also sometimes called as Z, that is also called as rank, or number of effective atom. For body center it is how much? 2. Now we'll discuss about the coordination number of BCC unit cell. So earlier definition already I have told that what is coordination number, that nearest neighbor atom that is directly contact with that specific atom or to a particular atom. In case of body centered cubic unit cell, just once again drawing this diagram. This is the body center and 8 atom are its corner. So suppose we are considering this atom. So for this atom, or we can draw like this, that this atom having directly, because take this, so 8 atoms, 1, 2, 3, 4, 5, 6, 7, 8 atoms are there, and one atom at its center. So that means this atom, the atom which is situated at the center of that unit cell, it is directly contact with this 4 atom as well as bottom side 4 atom. So we can diagrammatically also represent. So this is directly contact with this, this having directly contact, this is also directly contact, this is this. So this is one. Another way we can say, suppose these are the 4 atom which are situated on its face, top portion, and this is the body centered atom which is situated at the center of the body. So these are the 4 atoms on the bottom. So this atom will have on this and this layer, and this atom will be situated here, and this layer will be situated over this. So total coordination number for body center will be equal to 4 plus 4. So that will be equal to 8. For body center cubic unit cell, coordination number is 4. Next we will discuss about the relationship between its edge length and radius. Relation between edge length and radius in case of body center. Here also we will consider this edge length is A and R is the radius. So suppose this is body centered so there it is situated. So to find, because the atom which are situated on the upper layer on top face and 4 atoms are on the bottom face, directly making contact this atom. So we have to find the relationship between radius and its edge length, we need to draw a body diagonal. This diagonal is called body diagonal, and there also we will have to draw a line. So this is the edge length A, this is the edge length A, this is the edge length A. So if these are the two edge length A, so what will be this length according to Pythagoras theory? According to Pythagoras theory, this length will be is equal to root 2a. So that means we will get this one. I am drawing only this portion now, and along with this body diagonal. So this is the A This is the root 2a. Look, have a look once. Okay, this is according to Pythagoras theory. Now this angle is also 90 degree. We can easily find out this length. So this will be equal to, according to Pythagoras theory, a square plus root 2 this length. So this will be equal to a square plus 2 a square, that will be equal to x square. So we can find 3s square is equal to x square. So that is x will be equal to root 3a. So that means this body diagonal length is the root 3a. It's okay, everybody? Now we'll find the relationship. Now look here. This is the body diagonal. This is a, this is root 2a, this is root 3a. So here one atom, sorry. Here one atom is present, here another atom, and to this body centered atom is present. So from this diagram it is clear that this length will be the r, this length will also be the r. So here that will be twice r. So that means what we can do conclusion, root 3a will be equal to 4r. Once again repeating, this body diagonal having directly contact with this atom, centered atom, and this atom, and this length we have found it out already, root 3a. So root 3a will be equal to 4r, or we can say 4r will be equal to 4r is equal to root 3a, or r will be equal to root 3 by 4a. So this is in case of body center. So in case of body center, what is z or rank? That is 2, coordination number 8, and relationship between edge length and the radius will be equal to r is equal to root 3 by 4a. Last one is the FCC. FCC or face centered cubic unit cell. So here atoms are at each corner of the cell, and atoms are at each faces. So let's draw the diagram for FCC. So in case of FCC unit cell, atoms are situated at each corner, along with 6 atoms are situated at 6 phases. One atom on these phases, one atom on these phases, on top and the bottom, and one atom behind the board and one atom in front of the board. So total 6 another atom will be present on 6 phases. Now we'll find out the numbers of atoms contributed for this FCC unit cell. Corner, how many corners? 8 corners. Number of atoms at each corner will be equal to 8, and contribution of each atom will be equal to 1 by 8. So that will be equal to 1. Now phases. How many phases for a cube? It has total 6 phases. 1, 2, 3, 4, 5, 6 phases. Now most important thing, that is contribution of this phase atom. So suppose the atom is situated on these phases. So half phases means like this. Half of the atom will be there in this unit cell and half part of this atom will be there in another unit cell. So contribution will be equal to half. Atom will be half in one unit cell and half in another unit cell for the phases. So contribution will be half. So total numbers of atom, total number of atom per unit cell of FCC will be equal to 4, or Z, that is rank, will be equal to 4 in case of FCC. Once again telling, 8 atom, contribution 1 by 8 at corner. So total numbers of atom contributed from the corner 1, and 6 phases, 6 atoms are situated, and each atom will contribute half of it to that unit cell. So that will be equal to 6 into half, that will be equal to 3. So total numbers of atom contributed for per unit cell for FCC will be equal to 4. That is rank of the FCC unit cell is 4. Coordination number for FCC. So suppose this is FCC. So the center atom coordination number will be equal to 4 plus 4 plus 4, that will be equal to 12. How it is 12? See, one atom, it is phases. So this atom is directly contact with another 4 atom on this phases. Same way in from another unit cell will be there in contact. So 4 plus 4, and this phase atom having directly contact with that 4 corner atom. So total 4 plus 4 plus 4, that will be equal to 12. Coordination number for FCC is the 12. Now last one is the relationship between edge length and radius of the atom. Relation between edge length and radius in case of FCC. Let's draw at each corner 8 atoms and 6 atoms are on its phases. 2, 3, 4, 5, and on that back 6 atoms are there. To get that, we need to draw a phase diagonal. Phase diagonal. This is called phase diagonal. Phase diagonal. Alright? Or in another way, we can draw the atom. This is one atom at corner. These are the corner atom. These are the corner atom. So this is there. This is the phase diagonal. This is the phase diagonal. This is the edge length A. This is the edge length A. So from there, earlier also we have find it out. This length will be the root 2 A. So now we can find from there It's okay. So this will be the root 2a. So now we can say once again root 2a, and this length will be is equal to 4r. Therefore, r will be is equal to, we can write root 2a, root 2a by 4, or we can say a by 2 root 2. So for face centered, relationship between radius and edge length will be equal to, radius will be equal to a by 2 root 2, a by 2 root 2. Coordination number for FCC, it is 12. Effective number of atom or rank will be equal to 4. Last one is the end-centered cubic unit cell. Here it has atom, at each corner and two opposite phases. It looks like this. So it has 8 atoms at its 8 corner, and 2 atoms are situated on its opposite phases. Now we will find the numbers of atoms that is contributed per unit cell for end-centered cubic unit cell. So corner 8, contribution 1 by 8, that will be equal to 1 atom. Opposite phases, two opposite phases. So for phases, same way, just like phase center, if the atom is situated on its phases, so half part, suppose on this blackboard one atom is situated, so half part will be on inside and half part will be on towards the board. So 50% will be contributed. So that will be equal to half, that will be equal to 1. So total number of atom contributed per unit cell is equal to 2. So for end-centered cubic unit cell, number of atom contributed for per unit cell is the 2, that is Z will be equal to